Dear students, we'll continue with our chapter surface chemistry. So here we'll see about adsorption isotherm. So in this isotherm, we'll talk about Freundlich adsorption isotherm. Okay, you know the term isotherm. Isotherm means it's a graph in which the temperature is taken as a constant, right? So Freundlich has given the one equation, that is x by m equals to k p to the power 1 by 2, where n is always greater than 1. And x, what is that? X is the mass of the gas adsorbed, and m is the mass of the absorbent, and this p, k and n's are constant, right? So now this is the graph we have plot according to this equation, right? So what we have to analyze this graph, that is called Freundlich adsorption isotherm. So we have this is the graph at temperature T1. Temperature is constant, remember. Okay, so you have to think for a system, right? So we have some absorbent and we have some gaseous particle here, and it is a sealed chamber. Okay, you can put one piston here. Okay, right. So initially at temperature T1, right, so it will have some adsorption. The gaseous particle will adsorb at certain pressure. Its pressure is applied from here, P. Okay, pressure. At certain pressure, there is one answer. So we are increasing the pressure now. We are applying the pressure in the piston. So volume decreases. That means the pressure increases in the system, right? So with the increase in the pressure, so I'm moving from 0 to this side. Okay, and I'm increasing the pressure. So with the increase in the pressure, what will happen is that the rate of adsorption increases. So x by m implies the rate of adsorption, right? So with the increase in the pressure, the more number of particles gets adsorbed at the surface of this absorbent, right? So with the increase in the pressure, but after some time, a saturation point gets reached. Saturation point means no more particle gets adsorbed at the surface, no matter how much pressure you are applying. Okay, you can keep on increasing the pressure, but the rate of adsorption does not increases. That means it reaches this value. That means it moves now parallel with the P. So this is adsorption. This height is your adsorption. So with the increase in the pressure, initially the adsorption increases. So it's going up. So adsorption increases, right? So increasing. But if after some time, okay, after some pressure, it moves like parallel with this x-axis. That means you are applying the pressure, you are keeping increasing the pressure, but the adsorption is not increasing, right? So this is called saturation point. So for this T1, now if we increase the temperature, suppose T2, what will happen? See this curve. So the rate of adsorption decreases, right? So the graph is little bit lower side, at the lower side. So with the increase in the pressure, the rate of adsorption increases, but not that much as earlier one, because we have raised the temperature by T2. Okay, fine. For the same composition, everything is same material, same amount of material, same amount of gas, right? Again we are increasing the temperature, now T3. Okay, for the same system. Now we are doing again the same process. So what it has been observed, that with the increase in the pressure, the rate of adsorption increases, but not that with earlier one. Fine. Okay, so this one. So after some time, again in this curve also we reach the saturation point. Here also we reach the saturation point. Now we have to analyze this graph. No, so first conclusion we can make is that initially with the increase in the pressure, the rate of adsorption increases. Number 1 point. Number 2 point, after some time it reaches a saturation point where no matter how much pressure you're applying, the rate of adsorption does not increase. Okay, the amount of adsorption does not increase. Right. That is the number 2 point. And number 3 point is that with, okay, we are talking about this pressure. Okay, so here point, here. So for the same pressure, with the increase in the temperature, so T1, T2, T3, with the increase, I'm going down, with the increase in the temperature, the adsorption decreases. Okay, the amount of adsorption decreases from, for the same amount of pressure, this much, with the increase in temperature, the amount of adsorption decreases. Now we'll look at mathematically. It's 1 by n. Okay, the case 1, when 1 by n equals to 1, that means x by m is equals to kp, right? P is the pressure here. So that means x by m is directly proportional to the pressure here, because the power is 1, right? So this is the initial condition. When the pressure increases, x by m is also increases. The adsorption is also increases. The amount of adsorption also increases. So this is the case 1. Now case 2 is when x by when 1 by n is equals to 0. Okay, when x 1 by n equals to 0, that means any number to the power 0 means 1, that means x by m equals to k, right? So it does not depends on the pressure. So this is the one. So how much pressure you are applying, so this is the where I have called it the saturation point has been raised. So it is independent of the pressure. The x by m is always constant. Okay, so at this is high pressure. Now for the solution phase, x by m equals to k c to the power 1 by n. Now the pressure is replaced by the concentration. There are many applications of adsorptions, like number 1, production of high vacuum. So even remaining traces of air can be adsorbed by charcoal from the vessel evacuated by the vacuum pump to a very high vacuum. Similarly, in gas masks it is used, right? Activated charcoal is used to absorb poisonous gases. Control of humidity, we have already talked about silica gel. Okay, similarly aluminum gel also can be also used. Removal of coloring material, like in the sugar solution we have to talk about. Like heterogeneous catalyst, in which like solid catalyst has been used, right? Then normally the reaction takes place at the surface of the catalyst. So catalyst works in the principle of adsorption. Separation of inert gas, right? Curing diseases, flotation process, absorption indicator, then chromatographic analysis. So these are the basically applications of your adsorption.